Series. Okay, here we go. So find the sum or explain why the series diverges. So we're going to use the definition of a convergent sequence. First of all, we're going to take this summand, as it's called, and the form of this summand immediately brings to mind partial fractions. So we will do that. Skipping the details. What's it going to be? One of these is going to be 1, the other one's going to be -1. So let's see. A is 1. B is -1. Anyways, I'm not going to show all the details. This is the sum of 1 over n minus 1 over n plus 3. Okay, so using the definition of a convergent series, let's see. So we start calculating the sequence of partial sums. S1 is just A1, which is 1 over 1 minus 1 over 4. What's going on there? S2 is the first term plus the next term, second term. And S3 is first term plus second term plus third term. So n is 3. And n plus 3 is 6. So S1, S2, S3, S4, S5, this is a sequence. We want to see if this sequence converges or diverges. Now, what do we see? We don't see much yet. I'm going to do one more term in this sequence. And we're going to see, hopefully, something happening. So the next one you get, oh, come on, computer, work. 1 over 4 minus 1 over 7. And here we're starting to say, aha, look, minus a quarter, plus a quarter. It appears as though cancellations are happening. So let's start thinking about the general term in this sequence. So what do I get? Oh boy, here we go. Let's write it all out. So I'll write 4 or 5 terms. Just start. Let's do one more for now. 1 over 5 minus 1 over 8. And this is plus dot 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 plus. So we're talking here about the nth term in the sequence of partial sums. Maybe I'll throw in one more term here. you know, we're trying to see cancellations here, so often more is better. Okay, if I look at S4, look at S4 for a second. When I had 4 here, I ended on 4 here. Okay, for that reason, when I have N here, I'm going to end on an N appearing here. Minus 1 over N plus 3, yeah, N plus 3. Now, starting here, underline, okay. Starting here and moving right to left. Let's look at S4 again. You know, if I start at the end here and move backwards, I subtract 1 from 4 to get 3. And I subtract 1 from 7 to get 6. So my next term down here is going to be 1 over N minus 1 minus 1 over subtracting 1 from N plus 3 gives me N plus 2. And as I move right to left, I just keep on subtracting 1. And I will fill in the blanks. And one more. I know that N is all messed up. Okay. So what I'm trying to do now is look at this S capital N and decide what survives and what does not survive. So I got minus 1 over 4 and then plus 1 over 4. Okay, then I have plus 1 over 5 minus 1 over 5. New color. Plus 1 over 6 minus 1 over 6. Okay, on the other side of things, I have just kind of scanning it here. Okay, the first thing that pops out of me is this plus 1 over N minus 3 minus 1 over N minus 3. Okay, running out of colors here. Okay, now, oops, that's a mistake. Okay, my stuff in brown is a big mistake. Oops, start over. Where was I? Looking at the tail, we see the tail of this sum. Trying to decide what cancels on the end. Here we go. Plus 1 over N minus 1 over N. There we go. This is looking better. What else? What kind of colors do I have left? Not much. Oh, I'll use a nice, whatever, light blue here. Plus 1 over N minus 1. Ew, minus 1 over N minus 1. Black. N minus 2 minus 1 over N minus 2. So I'm going to circle in, I'm out of colors. I'm going to just circle in gray. Why not? What is surviving? Surviving, surviving, surviving. And that appears to be it. This 1 over 7 here, minus 1 over 7, I can tell is going to cancel with the next term that I haven't drawn here. There's going to be a plus 1 over 7 there. And likewise, the minus 1 over 8 is going to go away, the minus 1 over 9 is going to go away. Okay, at the tail of the sum, n plus 3, 1 over n plus 3. Why is that surviving? Well, it's a minus 1 over n plus 3. Is there a plus 1 over n plus 3 to cancel it? No. The highest I get with pluses for the denominators is this guy right here, plus 1 over n. So the n plus 3 stays, n plus 2 stays, and plus 1 stays. But everything else is gone. Okay, that's a bit complicated, but what I get is that S capital N is 1 over 1 plus 1 over 2 plus 1 over 3 minus 1 over n plus 1 minus 1 over n plus 2 minus 1 over n plus 3. So this is S capital N. Okay, so this collapsed. We call this a collapsing sum, or more commonly a telescoping sum. Okay, it is collapsing the way a telescope would. When a telescope collapses in on itself. Okay, this is nice because now I can just look at this last expression and I can say limit of Sn, remembering limits of sequences are always n goes to infinity, is just 1 plus a half plus a third minus 0 minus 0, come on, minus 0. So that is 6 plus 3 plus 2 over 6, which is 11 over 6. Come on. So, this is, so I conclude therefore summation 3 n plus 3 is equal to 11 over 6 convergent.